Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into how we can ingest data into a vector database. Here specifically in this particular video, we are going to use Milvus vector database into which we are going to feed some sort of data. The data will be in the form of a PDF. Let me show you that particular PDF. I'll simply provide you the link to that particular PDF in the description box. So here is the PDF. You can see the PDF is of around 6 pages. First part contains the photosynthesis process with the chemical reactions and also the different theories behind it. The second part of the PDF contains about the human nervous system. In all, I tried to involve all the different kinds of markdown stuffs that a PDF can contain, and we'll be seeing how we can simply feed this particular data into the vector DBs. So without further delay, let's start. I'm here inside the VS Code. Here I have simply created a data ingestion.ipynb file. Inside this file, we'll be writing some sort of code. We need to make sure that whatever libraries we are going to use in this particular code, all must be installed. And you know how to install it. And if you are facing any trouble installing that, you can simply ask me in the comment section. Now, since our data is in the form of PDF, we'll have to first extract the content in that particular from that particular PDF so that we can create chunks out of it and we can simply put it in the vector DB. So for that particular thing, I'm using LangChain's PyPDF loader. You can use your own custom document loader, but for now, our goal is just to have a look at how we can simply push the data into the vector DBs. So that is why I'm using the LangChain's PyPDF loader. So for that, I'm simply going to write from LangChain dot document loaders. We'll simply import the PyPDF loader. So let's create an instance of this particular PyPDF loader. Inside this, you just have to pass in the path to your PDF file, and then we'll simply load this particular loader. So let's do that. Loader dot load, and let's try to print the document variable. You can have a look at here that it loads the content page wise. See page 1, page 2, page 3, and so on. And also there is an advantage that here the PyPDF loader will automatically convert the content into a document object. Now if you want to know about document object, you will have to have a look at the chunking strategies that I have explained earlier in this particular generative AI playlist. So I would recommend you to first have a look at it. Now in this document object, you can see with the page content, we also have the metadata. Now over here inside the metadata, we can clearly see we have the source and the page. Source is what you put inside the path in the PyPDF loader, and the page is the by default the page numbers that are present inside our PDF. Now out of the chunking strategies, I am going to use the recursive character text splitter strategy in this particular video. So let me write the code for it. From langchain dot text splitter, we'll simply import the recursive character text splitter, and then we'll create an instance of it. So text splitter recursive character text splitter, and inside this we'll simply pass in the parameters, that is the chunk size. Let's keep it 1000, and then the chunk overlap, let's keep it 200. Now it is recommended that your chunk overlap should be at least 20% to your chunk size, but you can play with the values as per your use case. Now once we create the object, we'll simply create chunks. So let's define the variable chunks, and inside this we'll use the instance text splitter dot. split documents. Now over here we are using the split documents function because we already have all our data in the document object. Inside this will pass the document variable inside which we have the entire data. So this is just for displaying purpose. For chunk in chunks, I'll simply print each chunk so that you can clearly see how it has got created, and then I'll simply put a separator over here. So let's execute this, and here you can see that we have got our chunks. Here you can see that this is our very first chunk, this is the page content, and this is the metadata of it. Similarly, we have the other chunks. So I'll simply open the text editor over here, and here you can see the different chunks that has got created. So now that we have got our chunks, now the next step is to convert these chunks, that is the textual data, into the embedding data. Now we can simply do that with the help of an embedding model. We are going to use an open source embedding model from Hugging Face. The model that we are going to use is from Alibaba NLP. The name of the model is GTE Large. Using that model, we'll simply write this particular code from sentence transformers, import sentence transformer. Now we'll create an instance of our embedding model, that is the variable embedding, inside which we'll call this particular module sentence transformer. Here you need to pass in the model name. Here the model that I'm using, it is this. So I have just pasted the path to that particular model that I have got from Hugging Face. I'll simply put in the link in the description box. Just pass in the second parameter, that is trust remote code equals true. And you can simply execute this particular cell, and your embedding model will get loaded. For the very first time, if you are executing this cell, it will take some time, so have some patience. Now that our model is loaded, we'll simply test it. So we will try to create embedding of one sentence. So we'll use the encode function inside the embedding object, and inside this we'll pass in some text. So I'll write my name is Yash, and I'll simply execute this. So here you can see we have gotten the embeddings of this particular text. Let me check the length of the embedding that is created. Here you can see the dimensions are 1024. So it captures the semantics nicely. So now that we are ready with our embedding model, as well as we are ready with the chunks that we are going to feed into the vector DB, let's now connect to our vector database and write the piece of code to push this particular data into the vector DB. So as I said, I'm going to use Milvus vector DB. So make sure your Milvus is in running state. If you are using Milvus using Docker, then make sure the instance is running. And to have a look at the insights of Milvus, you can simply use this Attu UI. If you want the setup of Attu as well as Milvus, then you can simply have a look at it from the generative AI playlist. I have explained there step by step how you can set up Attu as well as Milvus onto your local system. So now that we are connected to our database, we will now push the data into the Milvus DB. Now you store data in Milvus in the form of documents. They are also termed as chunks. Now the chunks are stored inside the collection. You can just imagine a collection as a table inside the SQL database. And this particular collection inside the Milvus is stored in a database. You can imagine the hierarchy. First comes the database, then comes the collection inside it, and inside the collection you can have multiple documents. Now the collection has a particular schema, that is what all fields it includes. There is one single compulsory field, that is the vector embeddings, and that is why this vector DBs are termed as vector DBs and not only DBs. because there is a special field called as vector embeddings inside it. So that one field is compulsory. Apart from that, we can have multiple other fields. We'll have a look at it once we push the data inside it. So as per the hierarchy that I have told you, first comes the database. So very first thing that we have to do is to create a database first. So for creating a database, we'll first have to utilize the PyMilvus library. So I'll simply write the code from PyMilvus. We will simply import the connections. Then we'll also import the DB, and then we'll also import the utility. So first we'll create connection with the help of the connections. So we'll write connections dot connect, and inside this we'll simply pass on the host and the port onto which our Milvus instance is running. So the host is the local host. We can simply write localhost here, and then the port is the default port of Milvus, that is 19530. So over here you can see the connection has got established because our Milvus instance is running successfully. Now we will check the available databases. So I can simply write db.list database and execute this. So over here you can see there is one single default database. Now we'll be creating one database, and to create a database you have this particular simple function called as create database. So let's write db.create database, and inside this we'll simply specify the name of the database. So let's say the database name is first db, and we can simply execute this. So our database has got created. Now again, if we try to run this particular db.list database command, we'll be getting the database first db. Also you can have a look at the Attu interface. So I'll simply log out from here and I'll simply log in again, and you can now see we have the first DB database that is created. Whatever changes or whatever data we are going to push in the vector database, we are going to do it inside the first DB only. So that is why we'll simply point the first DB as the current database. So for doing that, we'll write db dot using database, and inside this we'll simply specify the name of the first DB database that we want to be used currently. Let's execute this. Now to check the list of collections inside this particular first DB database, we can simply use the utility dot list collections function, and with this you can get the list of collections. Currently our first DB database is empty, that is why there are no collections inside it. There is a procedure to create a collection because collection contains certain specific schema. We'll have to define the schema fields, we'll have to define the parameters every single field should contain, and then we can simply create the collection. So let's have a look at it now. Now we'll be creating our schema. Now as I said, that schema is the structure of our collection. It defines the different fields that it involves, as well as types of the each field is specified at the time of creation of it. So we are going to create a schema now. Now taking a look at the data that we have, over here you can see we have three things to store. The very first is the page content, that is by default what we have to store. We are going to store the embeddings of these page contents. Next thing that we want to store is the source of this particular document. The source is nothing but the path from which this particular document has got retrieved, and then the page, that is nothing but an integer value at what page it is exactly located. So now that we know that we have to store three different things, we'll simply specify three different variables. So our very first field will be the source field. So let's write source field, and to create fields we have the inbuilt functionalities inside the PyMilvus. That is nothing but field schema. So we'll simply import from PyMilvus. I'm simply adding on this field schema. Then we'll also use the data type, and then we'll use the collection as well as the collection schema. Let's run this again, and now we can simply use the field schema. Field schema attribute is used to create a field. It is used to define the structure of the field. So inside this we'll pass on the different parameters. First is the name. So name of this field will be source. Whatever you specify here, the same will be reflected into the Milvus collection. Next thing is the D type, that is the data type. Here we are going to use the data type string, because our source is nothing but the path, and a path is always a string. So we can specify the max length parameter, and let's set this to 255. Then we can also specify the description of this particular source field, but for now I don't want to specify it, so I won't use it. Then I will also write the is primary field. I'll set it to false, because I don't want this source field to be a primary key. Similarly, we'll be specifying two more such fields. The second field that we are going to specify over here is the page field. Now the name would be page, the data type would be integer with 64-bit. I don't want to specify these parameters. Now we'll specify the main field, that is embedding field. Let's name this as embeddings. The data type would be float vector. Here we have to specify the dimensions. So we can specify it with the help of the parameter dim, and we will specify 1024 as the dimensions, because our embedding model generates the embeddings with the dimension of 1024. Now with this embedding field, if you want to store the original data in the form of text, that is the page content, then you can also specify one more field of storing the actual textual data, that is the content. So we'll specify the field content field. We will name this as the content. We'll keep the data type as string, because the content is in the form of string. And then we can specify the max length over here. Let's specify it as 2048. You can specify as per your wish. So now we have defined all the variables into which we have defined the schema of every single field. Now to create one single structure, we'll use the collection schema. Now over here, let's define a variable schema, and here I am going to call the collection schema from PyMilvus, inside which we'll have to specify fields in a list. Inside this list, I'll be specifying all the fields that I have created earlier. That is the source field, then the page field, then comes the embedding field, and lastly comes the content field. Now make sure about the order. Here as a second parameter, I can also specify description, but for now I am keeping it empty. Now let's try to execute this. Okay, so we have got one exception, that is primary key exception. We haven't specified any primary key field. If you know, every single collection should have a primary key field to uniquely identify a particular row. So we haven't specified that yet. So let's do that first. So here we'll specify an ID field which will act as a primary key. So let's name it as ID field. The name of the field will be ID. The data type will be integer 64 bits. Let's keep it is primary as true, and then we will set it as auto id equals to true. Now this auto id equals to true will create an id according to the data type that we have specified automatically, and then we'll also store this particular id field in the fields list inside the collection schema. Now it should work. Let's try to execute this. So over here you can see we have successfully created our schema object. Let's define a variable collection, and we'll use the collection class inside the Milvus. We'll specify the name of the collection as science, and then we'll set the schema of this particular collection with the schema variable inside which we have defined our schema of our collection. Let's try to execute this. Okay, we have got an error saying that string data type not yet supported. Please use varchar type instead. Okay, so here instead of using string data type, we'll simply use the varchar. So let's execute this cell again to create the schema, and after that we'll simply execute this cell of creating collection. Now you can see that our collection has got created. Now just to check whether it has got created successfully, we can simply check this using this particular function, that is utility dot list collections. You can see our science collection has got created successfully. Collection dot load. Let's execute this. Okay, so after executing this, we are getting the Milvus exception stating that index is not found. Now, what is an index? Now, inside a vector database, it stores the document in a particular format. It stores it in a particular structure so that whenever we try to retrieve it or we try to perform query search operation, it will optimally search for that particular relevant documents which is the closest to that particular query. We have already closely seen how an index works. I have already explained what are indexes in vector DBs as well as what exactly are the different types of indexes. I have also explained you the mathematical intuition behind the working of HNSW and the other types of indexing in the generative AI playlist. You can have a look at it. So inside a vector DB, you will have to create an index, and that is why whenever I am trying to load the collection, it is throwing me this particular exception. So first we'll have to create an index. We are going to create an index with the help of HNSW algorithm. So you don't have to worry about it. Everything is inbuilt in here. We just have to call it and set the parameters. So for creating an index, we'll have to first set the index parameters. So I'll be creating a dictionary inside which I will put all the necessary parameters. So first I will set the metric type. So metric type is a parameter which tells on what basis you want to perform the query search, on the basis of similarity or on the basis of distance. I will use the Euclidean distance, that is L2. For more different types of metrics, you can have a look at it in the official documentation of Milvus. I will simply post the link to that documentation in the description box. Then we'll specify the index type. Now I'm specifying HNSW, that is hierarchical navigable small world. Next I will include a sub dictionary inside this dictionary which will state the parameters to this particular index type. So the key will be params and the value will be a dictionary. Inside this, I will state the m value, that is the number of neighboring links. I will set this to 16, and then the next parameter is ef construction. I will set this to 200. Now we are done with specifying the index params. Now we'll execute this. Now we'll simply create an index. So we will write collection dot create index. Now this collection variable contains the collection that we have created earlier, which contains the specified schema. Now we'll create an index. Inside this, we'll simply specify the field name onto which we have to apply this particular index. The field name is embeddings. Next, inside this, we'll pass on the index params as the index parameters that we have defined in a dictionary. So we'll specify it. Now let's try to execute this cell. So here you can see we have successfully created our index to this particular field embeddings. Now let's try to load this particular collection. Now you can see our collection has got loaded successfully. Now let's go into the Attu interface and have a look at whether our collection is getting reflected or not. So now you can see over here inside the first DB database, we can simply see the collection signs that has got created. Now if you look inside this particular collection, you can see that this is the specified schema. The ID, it is the type, it is of the type integer 64-bit. We have the source, we have the page, we have embeddings, we have the content, we have all this. And you can see clearly that the field embeddings has the index type as HNSW. The metric type is L2 that we specified in the index params. The M value is 16 and the EF construction value is 200. If you look at the data tab over here, particular collection is empty. Now we'll try to push the chunks that we have created into this particular collection. You need to make sure that whenever you are going to push the content into the collection, the data that you are going to push, it should be in the same order. It should be of the same type as well as it should be of the same format that is specified while creating the fields of the collection. We have our data in the variable chunks. From this, what we want source, we want the page number, we want the page content, as well as we also have to create the embeddings of this page content. So we'll require 4 variables. So let's create all the 4 variables. So the first is source. So what we can do is we can simply create a list of all the sources that we have in this particular order from all the chunks. So I will write using the list comprehension for chunk in chunks. Now what I want from each chunk, I want the chunk dot metadata, because this source is present inside the metadata field, and inside this I want only the source attribute. So I will get list of all the sources in the same order in which these chunks are present. Similarly, I'll fetch the pages, or I would say the page numbers. So what I want for chunk in chunks, what I want chunk dot metadata, and inside which I want the page. So I'll specify it over here. Next, what I want the page contents. So I will name it as page contents, and for chunk in chunks, I can simply fetch the page content like this dot page content. I'll get the page contents of all the chunks in the form of a list. Next, what I want is the embeddings. So I'll specify content embeddings. So here I'll have to create embeddings of every single page content. So how to create an embedding? We already have loaded the embedding model in the variable embedding. We can use the encode function, and we can pass in this particular page content inside the inside that encode function to get the embeddings. So we will write embedding dot the encode function inside it, and we'll pass on the chunk dot page content inside this encode function. This will make sure that the embeddings will be created of each page content in one dimension, and it will be stored in this list. Now let's try to execute this particular cell. It will take some time because our embeddings are getting created. So you can see now this particular cell has got executed successfully. Now let's check whether we have got the same thing what we have expected. So over here we have got the page contents correctly. Then let's try to check the content embeddings. Yes, here we have got an here we have got a list of arrays of one dimensions, that is nothing but embeddings of each and every page content. Let's try to check for the pages. Yes, we have got the page numbers, and let's try to check for the sources also. Yes, we have got the sources. Now that we are ready with these variables in which the data that has to be pushed is ready, now let's try to write the code with the help of which we can simply push this data into the Milvus database. Now for inserting, we have a function named insert inside the collection object that we have created. So collection.insert. Now inside this, we will have to pass on the list of variables inside which we have the data in a list format, and make sure it is in the same order in which you have specified the fields of the collection. So over here you can see that first we have specified the source field, then the page field, then the embedding field, and then the content field. So let's do that. So first we'll push the sources. Next we'll push the pages which contains the page number. Next we'll push the embeddings because our third field is embeddings. And next we'll push the page contents which contains the textual data of the embeddings. So let's try to execute this particular cell. Here you can see it has got successfully executed. Here the insert count is shown, that is 10 chunks, or I would say 10 documents has got inserted. Then here the success count is also shown, that is 10. All the 10 documents has got successfully inserted. Now let's try to check using the Attu interface. So over here you can see that our data has got successfully pushed. You can see the ID, which was an auto-generated field, it has got successfully created for each and every document. Then comes the source field. Here whatever path we have specified is now successfully over here. Then the page field which contains the page numbers, the embeddings field which contains the embeddings of each and every document, then the page content field which contains the content of every single embedding over here. Every single thing has got inserted successfully. So I hope every single thing that I have explained you in this particular video is crystal clear to you all. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. For more such videos, do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.